Okay, and we are recording. We're talking about the chapter one PowerPoint, and we're about a third of the way through it, and we're going to finish up the PowerPoint now. This lesson is primarily about strip diagrams. Before we start talking about strip diagrams, I want to talk to you a little bit about, again, the way that a child sees math and the way that one of your students in one of your elementary school classrooms will read and interpret a question like this. So let's read through it together, and then let's look at what one of the students answered, and then let's look at how it appears to us as teachers. A carpenter has a board 200 inches long and 12 inches wide. He makes 4 identical shelves and still has a piece of board 36 inches long left over. How long is each shelf? Let's take a look at what this student drew. At a first glance, when I look at this picture, I imagine it looking like a three-dimensional figure. It looks to me kind of like this is a Coca-Cola box, like a box that is holding Coca-Cola cans, or maybe a box that you get when you order sandwiches from an Italian restaurant. It looks like a box that has flaps that have been broken and folded down. But if you look very closely, right here, this is not a flap. This is kind of more like a bracket or like an indicator of this length is 200 inches. This length is 12 inches and so on. So if you take these out and just put these numbers here, then it does look a little bit more practical. The reason why this is being brought up is because this is another case of a situation where a student is doing their best and actually really doing a very good job, but it could easily fall to the wayside because the initial look, the initial drawing, it looks like the child thinks that we're doing three-dimensional things here. And in a way, for this kind of question, we kind of are thinking about some three-dimensional things, but it is, after all, about a rectangle and cutting a rectangle into pieces. So let's see what the child wrote. It says, you subtract 200 from 36 and get 164. Now that number is the length of a board pieces he has. Then you divide that by 4, the number of shelves he made, and you get 41. So looking at this, there's a couple of things you can get out of this, and you can help the child a lot. You can explain to the child first when it comes time to draw brackets and try to indicate the way that you drew it this time makes it look a little bit less than what you meant. It looks like a three-dimensional figure the way you drew it. Why don't you try to draw it this way and show them what a fancy bracket looks like with a smooth curve in it. Also, there's wording here, and the student is trying their best to help to demonstrate that they understand things, and they want you to help them learn. You cannot subtract 200 from 36 in a case like this. You're actually subtracting 36 from 200. And one of your roles as their math teacher and their leader in the classroom is to always know confidently that there's no arguing that when you subtract 200 from 36, it's not the same as if you subtract 36 from 200. When you subtract 200 from 36, you don't get 164. You get negative 164. They don't know that yet. And that is probably one of the most challenging things for the children is the language of subtracted from and how you're supposed to reverse that. So this is a great opportunity to help a student who's a very good student to just improve a little bit more with the way that they indicate measurements on a diagram, and also with the wording of you subtract 200 from 36 and what that means and how to write that correctly. When you give an open-ended question like this, you are able to almost criticize or nitpick little flaws that you do see the kids have, and you can help them in a kind way to improve them. That's what a good teacher would do. Instead of looking at this and saying, this kid is all wrong, and I have to call this kid's parent, and I'm going to yell at this kid and say, I can't believe you would draw that diagram, knowing what you're not going to get anywhere with that. I said 100 times that if you subtract one number from another number, that you have to reverse them. I said it 100 times. Why aren't you listening? You have to be careful. You got to be careful how you talk to our kids. And if you see a kid carefully writing with a pencil, you subtract 200 from, they are trying very hard to learn something and to impress you. So remember, be gentle and say, you did a great job. This is wonderful. I love this drawing. You showed your work on the side. This looks really great. I just want to make sure that you know, when I first looked at it, it didn't look right, but I understand what you're thinking. I want you to learn how to write so that everyone can see what you're thinking. For example, the 200 inches, it should have a little bit of a smoother kind of bracket there with an indicator. The word from and subtract are very delicate. Let's make sure we say that right. Let's do a couple of examples. What does it mean to subtract 1 from 9? What does it mean to subtract 55 from 1,000? Can you subtract 1,000 from 1 million? Can you subtract 1 million from 1,000? If you ask questions like that and have a short conversation with a smile, before you know it, that child will never forget what it means to subtract from. And because you took that moment to help them, they will go the extra mile just to impress you, if no one else, and make sure that when they write 200 inches, they write it with a little bit of a different kind of indication. So let's take that opportunity to show kindness and to reach out to our children and to step into their role, look through their eyes and try to see what they're doing and what they're thinking and what they're feeling. This is an outstanding response to this question. And it includes a correct answer. Very well done. There's just a little bit in the critical thinking that's a little bit off, and we can kind of just tweak that and repair that. And that's what we want to do. Now we're going to talk about something that is really the central focus of this class that we use a lot, and it's called a strip diagram. And a strip diagram is basically a rectangle or a group of rectangles that represent quantities and that can be cut into pieces to represent parts of quantities. You can use strip diagrams for addition, subtraction, multiplication, for mixture problems. You can also use them for percent problems and other things. There's a lot of different reasons to use strip diagrams, and the reason why we're studying strip diagrams is because it is one of the most basic ways to express quantities in mathematics for the children. And if we can get our kids to use strip diagrams, we'll get them to be thinking critically with math a lot more than we thought. And it's good to keep them kind of in the idea of a visual image that goes along with whatever the quantity is and the idea of the numbers. So let's talk about this question. The library bought 576 new books. The library loaned out some of them. 198 were left over. So how many were sold? Okay, so as an adult, a second grade teacher in a career-oriented world, you're looking at this problem saying, yep, got to subtract, right? And I think we all understand that, and that's really great. It's a story problem, meaning that it's figurative and flowery language. You have some imagery. It's a book, a library with books, and they're loaning books. You have a little cartoon in your head of the librarian letting someone go by with a book and stamping the book or whatever the story is. Long and short of it, we're supposed to subtract. I know that and you know that. But when the child sees this, they're going to say, well, I'm going to let the library be the strip diagram, and then I'm going to cut out a part of it. Something like this. So the strip diagram is a long rectangle, as you can see here, and we've deliberately shaded one part of it to show that that means how many has been loaned, and then we also have that this is how many are left over, and we're trying to figure out the shaded part. For some students, for very many students, looking at this strip diagram along with the word problem makes it very clear what the operation is and how to come up with a solution for a question like this. I recommend that you try to practice with strip diagrams, coming up with answers and trying to come up with strip diagrams like this, right? So with that in mind, let's see if we can figure out some more ideas about strip diagrams. If it's time to do a question that's a story problem that has to do with subtraction, I'm going to encourage you to come back to this slide and take a look again at this example about the library. It's an outstanding example of how to use a strip diagram to solve a subtraction question. Then we have an addition question. We have two girls that have money together, Anna and Susie, have $28.90 all together. Anna has $5.48 more than Susie. How much money does Susie have? So if you look at this and you think about it, we'll draw a sideways rectangle. We're going to cut it into two parts, make the whole rectangle $28.90, make a small part of it $5.48. And then we're going to draw another rectangle directly under it to represent the Susie part. So we know that Anna and Susie are not equal. We know that they don't have the same. And I know that because $5 is less than half of this. So what I'll do is I'll draw them as two deliberately different long rectangles. Anna is significantly longer than Susie. Now, I don't know how much longer than Susie she is. I just kind of extended it more than Susie. So they have two different strip diagrams that are clearly different quantities. I do understand also that Anna and Susie have the same amount of money together, but Anna has more than Susie. So what I'll do is I'll extend Anna to be a little bit longer than Susie, like this, and cut it right where Susie is to show that this rectangle and this rectangle represent congruent or equal quantities. So that being said, I can then assume that if this whole thing is $28.90 added up, and this difference right here is $5.48, if I subtract $5.48 out of the $28.90, I get the total sum of what both of these rectangles is. So I'll subtract it. I'll get $23.42, knowing that both of these rectangles are $23.42. I'll divide that by 2, and that might take a little bit of long division on the side. Not really very hard to do, but I still would want to go through it. All right, so the first step here is going to be go ahead and subtract, right? Let me get a good view here. I don't really have a view of my camera, my paper. Kind of crooked. There we go. All right. So first idea here is we're going to do $28.90, and we'll subtract our 548. And when we subtract, we get 2342. My next step here is divide 2 into 2342. Little long division. We're talking about 11.71. So what is 11.71? Well, 11.71 is the quantity that is in each of these two rectangles because they divided the answer by 2, which means that this quantity is 11.71 and so is this, and therefore the answer to this question, how much does Susie have? Susie has $11.71. Now, please don't be afraid to draw more than one strip diagram. That's what this lesson is about. This story problem has two people and there's a difference between how much they have, but you know how much they have together. Can we remember that if we tell you that there's two quantities and they add up to something, one quantity is this much more than the other quantity. It looks like this. This is the strip diagram formation. You do two parallel strip diagrams, one on top of the other, just like this. And then after you draw the strip diagrams, you could stare at them and think for a little while, and it will come to you kind of what the procedure is. Oh, I think I should subtract $5.48 out. Then when I'm through with that, I guess I better divide my answer by 2 to figure out what Susie has. And Amelia, this is the question. I think this is the exact question that you asked. Let me look. Is it the same one? It might be the same one. That number looks familiar. Let's see. 5285. Yep, it's the same question. So here we go. All right. This is the very question that was asked up front, and we're going to do it now with strip diagrams. One number is 4 times as large as the other number is, and their sum is 5285. What are the two numbers? So instead of it being two girls that have a difference between them, it's two numbers that also have a difference between them, but it's not a difference, it's a multiplicative comparison where one of them is 4 times as large as the other. It'll look something like this. Your first number is a simple brick. The second number, you could lay down 4 bricks, right? And those 4 bricks represent the 4 times the first. And if you look closely, you'll notice that we do have 5 units in our picture. Also, we know that we're going to wind up dividing by 5 because that one extra unit does make it that there are 5 total, and we've shaded the first unit so that that is our unknown. That's what we're looking at today. So we've got our first up there, and we have 4 of them here. We add them all up, and then we divide it by 5, and we get our solution. Now, when we get our solution, that actually is the answer. If we wanted the second number, we'd have to multiply it by 4. So I'm getting a little bit of a message here that I see that some students are having internet problems, and that's okay, I understand. I see some of you coming in and out. I'm going to post this video shortly so that you can watch it again. And today, we are supposed to go until 9:15, but we're just about done with our lecture. So I'm going to pause it here, and after our lecture, we're going to all work together on the website. Okay, so guys, I hear that you're having some internet problems, and thank you for communicating that to me. Don't worry too much about that. We're going to have a chance to be able to look at the video later, okay? All right, and then we have one more strip diagram, and then we're going to close this, and we're all going to work on our web assignment, all right? Jacqui, Karen, and Lynn each own several bottles of nail polish. Jacqui has 12 more bottles than Karen, and Karen has 3 times as many bottles as Lynn. Together, they have 124 bottles of nail polish. How many does each person have? So let's look at these 3 girls. We have Jackie, Karen, and Lynn. And notice that if we know that Jackie can be compared just to Karen. Karen can be compared to Lynn. But notice we know nothing about Lynn. Lynn can't be compared to anyone. That's why Lynn is the shaded box or the unknown. If I knew how many nail polish bottles Lynn had, I could answer the questions, how many does Karen have and how many does Jacqui have? So let's start by thinking about Lynn. What we learned last time is when it comes to multiplication, like the question with the 5285, we draw many boxes. So we can make one of the small shaded boxes Lynn, and we can make Karen 3 times as many Lynns, right? And then Jackie is 12 more than Karen, so we can make it that plus 12 more. And something like this. So does that make sense, guys? That Lynn is going to be just one of those boxes, and then we've extended Lynn to look like 3 times as big as Lynn, but Lynn is really only this one box here. And we did that so that Karen measures up to Lynn. Karen is supposed to be the same 3 times as big as Lynn. So the dotted line tells you that Lynn is just this box, and now it's clear that Karen is 3 times as big as Lynn. Also, we're told that Jackie has 12 more than Karen. So on top of Karen, I just put a 12 like this, extended out. Karen is only this rectangle, not this part, and now that means Jackie is this part. So together, they all have 124 bottles of nail polish. It may become clear to you that you have to first subtract off the 12 from Jackie, right? Not from Jackie, I'm sorry. First, you have to subtract off the 12 and then divide it by 3 to get the Lynn, okay? So if it's 124 bottles of nail polish, we could start by taking 124, and let's get the camera going here. Okay, so we're talking about a strip diagram, and looking at this strip diagram, we can see that we're going to start by taking 124, okay? And, oh, we have some people coming in again. We're going to take 124, and we're going to have 3 parts for Lynn. So it's only one Lynn, and if Lynn is X, right, then we could say this is the same as 4X, right? Well, let's not say 4X. Let's say X for Lynn, okay, plus 3X plus 12, okay? And this is Karen, and then plus Jackie. Now, Jackie, if you remember, is Karen, so it's plus 3X plus 12 again. Karen does not have the 12, so it's just 3X. So let's start fresh, guys. Sorry about that. First, we have Lynn. If we let Lynn be X, we have Lynn equals X. So we have X, right? And then we have, next to X, we have Karen. Karen is 3 X's. And then next to Karen, we have Jackie, and Jackie is 3X plus 12. We expect all of this to add up to 124. It may become clear to you, looking at this, that Jackie is actually 3 Lynns as well, plus the 12. So you can draw a couple of different strip diagrams to make this clear. Maybe it would be a little bit easier if I drew it to look like this. That's Lynn. Now you have Karen. And now you have Jackie. Looking at it this way, I have 1, 2, 3, 4, 5, 6, 7. I have 7 boxes. I also have 12 on top of it. The student can go backwards and start with 124, subtract 12, and then take 112 and divide it by 7. And you're going to get 16. That means each of these boxes is 16. And now we can figure out what all of the different amounts are. So the point that we're trying to make is the strip diagram that you see here in our PowerPoint is not the only end all and be all strip diagram that's possible. What we want the students to think about is subtracting 12 first and then dividing by 7 last. And for a question like this, if you draw it this way, it might become a little bit clearer. At least for me, it becomes more clear. Some students are going to look at our PowerPoint right here and think this is more clear. And like I said, I want you to always try to do it through the eyes of an adult first, using your algebra ability, and it'll help you to realize that it's supposed to be 7x plus 12, and that's the whole general concept here. And that's why we're hoping that the children will read this question, think about minusing 12 out first, and then dividing by 7, because there are 7 parts in the story, okay? So, not exactly the easiest thing to figure out. Remember to answer the question, how much does each person have? If one box is 16, then you can say Lynn has 16, right? You could say Karen has 16 times 3, which is going to be 48. And then you could say that Jackie has 48 plus 12, which is 60. And these numbers are going to all add up to your number, 124, when you add them up, okay? So I hope that helps a little bit. This is a great case of how to use strip diagrams for 3 quantities, and that comes about when you're doing your practice. I think I'd like to just write that one more time to make it really clear for everybody, and just go through it one more time. We're going to start by talking about Lynn. Lynn is going to be 1 block. Then we're going to talk about Karen. Karen is actually 3 Lynns, as we're told. So this is Karen, right? And then we're going to talk about Jackie, which is Karen, which is 3 Lynns plus 12. You can deliberately exaggerate the last strip because you know it's not equal to the others. That's why I made it longer looking that way. And this whole thing is Jackie. Because of this diorama here, I can see that there are 7 parts. 1, 2, 3, 4, 5, 6, 7. There's 7 equal parts. And we have 12 left over. So you begin with 124, subtract 12, then take your 112 and divide it by 7, you get 42. Each part now is 42. If it helps, tell your children to write it in there. Now it's really clear how to add up to get Jackie, 42, 42, 42, and 12, etc. Okay? All right. So we've come to the end of chapter 1. I want to talk to you a little bit about our agenda and what you can expect in the future here with our class. Let's stop sharing the okay. We're going to take a look at our syllabus together, and then we're going to break and work a little bit on WebAssign. Okay, let's look at the syllabus. So what you need to know, guys, now is when you're getting ready to prepare for your exam, there are 2 essays that you'll have to be able to submit for your exam. It's a smart move to open up a Word document and work on those essays, and I'm here with you in class until 9:15 today to make sure that you're comfortable with those essays, okay? That's what we're going to do with the rest of our time. In the meanwhile, I'm going to share with you our syllabus so that we could see what we can expect in the near future. Right now, I'm moving down to the calendar. If you look at the calendar here, right now, guys, we are right here, September the 10th, okay? Now, next week on Tuesday, you're going to have one more lesson on Tuesday about this material. And in that lesson, you'll have some practice that is associated with the exam, and a little bit of an exam prep. When I see you on Tuesday, I'm going to have a worksheet document for you, and we're going to work through it together. And if you're good at that document and you're familiar with all that, you'll be just fine when you take your exam. The exam is scheduled for Thursday, 9/17. Now, let me explain to you how to take an exam, okay? We're going to look at the exams. There will be 5 exams. They will be administered on the dates specified by our calendar. These exams are comprised of multiple choice questions, short answer questions, and essays. Students will be provided with the essay questions beforehand, and essays must be completed individually and submitted at the time of the exam. To prepare for exams, review lecture notes, PowerPoint presentations, WebAssign practice, and examples from our text. Since this is a live online class, your exam is scheduled specifically for this day only, right here, September 19th, which is a Thursday. Now, if you don't want to take the exam at 8 o'clock in the morning, that's okay, because it will be available for you all day. And when you go in to take the exam, which can be at any time on Thursday, from the moment you open it, you'll have 2 hours to take the exam. and then it will close at the end of 2 hours. You have to take the exam on Thursday because the entire class of students is eager to see what their grades are, and I'd like to make them public by Friday. When Friday comes, you should be able to see the answer key, and you should be able to see what you got right and what you got wrong. And also, I just want to make a word of caution, guys. These exams are only, so good. There may be issues with them. We may have something might slow us down, like there might be a question in there that was an unfair question. And if that be the case, which is almost always the case, there's always one question in there that slows us down. Remember that I'm going to make sure I take care of it and that you get a fair grade. I will remove the question if I have to. And if anything like that happens, if you see that your grade is not what it should be because of a glitch in the test, please don't get upset. Just communicate it to me. I'd be very happy to fix it. I'm really very into giving out points as much as I can. I think you know that about me. I hope you know that about me. So when you take the first exam on Thursday and you get your grade back at the end of the day, if you feel like there are mistakes in there, just send a very friendly, kind email, brief. I think number 2 has a mistake. I'll let you know, hey, number 2 has a mistake. I'm sorry, I adjusted it. Your grade has been changed. Okay? And if that be the case, we'll take it as it comes. Hopefully, we'll be able to have an exam that doesn't have issues like that. And we'll talk more next week about how to take your exam. And the exam will be in e-learning Blackboard. You'll be taking your exam. Okay, guys? So what I'm going to do now is turn on my camera because I wanted to just talk to you for a minute, and then we're going to take our break. Okay, here we go. So right now, my friends, it is 8:35 a.m. and our class goes until 9:15 a.m. So I'm going to ask you at this point to take a break. Let's come back at 8:50, and when 8:50 comes, you're still mine for 25 minutes. I'm going to ask you to go and look at those essays in your textbook. I'm going to ask you to try to look at the homework practice questions out of your textbook, and I need you to also go and check out WebAssign and make sure you're comfortable with all that material. And also, when we come back after our 15-minute break, I'll have our camera ready and the construction paper. So please go and collect questions from WebAssign that you feel are uncomfortable. I'll go through them with you today here with the time that we have. Okay? Let's take our break. Thanks for your attention, everybody. This concludes the Chapter 1 lectures. And from here on in, it's just practice until next Thursday when your exam comes. Before I close, does anyone have any questions or concerns? Okay. All right, we're going to stop here, and we're going to come back at 8:50. Thanks, guys.